Hello and welcome everybody to this webinar for security with Apache Spark and all the kind of operations and organizational stuff that organizations should be considering and thinking about and applying during their day-to-day. It's really good to have you all here, and I hope you're excited about today's session. I know I am. And I think before we start, I just want to make sure that if at any point throughout this session, anyone has any questions that they want to ask, we'll try and address them as much as we can. Just make sure to leave them in the comments so that we can get to it. So I think before we dive in, we should probably start with a little bit of an overview of the team that we have here. I'll start with myself. I'm Mark. Hi. I'm a software engineer working with the big data team with a background predominantly in ML ops and data engineering with large organizations. And with me here today is Rob Gibbon. He's a product manager for the big data team, as well as Massi, our information security team lead and guru. So could both of you give a bit of an overview of who you are and what your focus on is here at Canonical? Massi, why don't you start first?
Yeah, sure. Hi, Mark. Rob. So my name is Massimiliano Gori. I have spent most of my career in the area of identity management and cybersecurity incident response, which I did for a number of years at NCSC here in the UK, prior to joining Canonical. Here, I focus primarily on cybersecurity and different aspects of the product, working alongside with Rob, as well as other teams horizontally across the company.
Yeah, I'm Rob. So my background is in big data. I've set up about 40 clusters for clients in various industries in the past before joining Canonical. Building data integrations on top of those. Since joining Canonical, I'm focused on building out products in the big data space. So that's my focus. Hope that answers your intro needs.
No, it's great. Thank you. So for this session and webinar, we I think aim to have a slightly more informal discussion around big data security best practices and how hopefully tie that down to how they apply to safely running Apache Spark on Kubernetes and in production. Hopefully a lot of the people joining here today already have that set up, but if you don't worry. We'll start by giving a bit of a brief overview of what Apache Spark is, how it gets used, and what the common deployment patterns are, as well as exploring the motivations for and the identification of potential security attacks, and understanding what teams and groups can do to help batten down the hatches of any new or existing Spark deployments on K8s, and outlining what pragmatic and helpful steps teams need to be thinking about, need to be applying, both at an architectural and at an operational level. And I'll remind everyone just one more time, if you have any questions at any point, please feel free to leave them in the comments. So I think to start with, we can start talking about what is Spark for anyone that may be more unfamiliar. Rob, why don't you give us a bit of a walkthrough on what Spark is, the internals of how it works, then the sorts of problems that it solves, and what organizations typically use it for.
Oh, okay. So what is Spark? It's a software toolkit for building parallel distributed data processing jobs that run at scale over large amounts of data. The thinking is that if you can split a workload, like a very large data set, into discrete portions that can be assigned to different nodes in a compute cluster, then you can parallelize the work so that it goes faster. So you can have different stages of the process that parallelize and then gather data together and process a large data set in a more timely fashion than if you were to sequentially work your way through the whole data set in one go. Of course, if you don't have big data, there are overheads to running Spark that may not justify using it. So it's really for large data sets, terabytes or petabytes of data. So that's kind of what it is. Why is it useful? So it's useful if you need to, I don't know, pre-process data for feeding into a machine learning model, for example. For large-scale extract, transform, load jobs, or for reporting and analytics at scale, say on, I don't know, clickstream or other kind of evented data that you've gathered in a data lake. You may wish to batch process that data overnight to gather insights from it, or you may want to run it as a continuous process. So Spark also supports a continuously processing mode of operation called Spark streaming, so that you process data as it flows through your environment. Whether that's things like clickstream or other kinds of event stream data. So that's kind of why you might want to use it, and then there's kind of how would you use it. So you develop jobs using Python or using Scala. There is also support for Java and for R, but it's kind of less developed. But so typically users are using Python or Scala to develop their applications, their Spark applications. When you've got a job that you want to run, you use a bunch of command line tooling from the Spark solution to launch your job on a compute cluster. So whether that's a Yarn cluster, so in the past, Spark was very closely aligned with Hadoop and with Hadoop's resource manager called Yarn, Cluster Resource Manager. These days, it's kind of moved more towards Kubernetes, so hence we're focusing here on Kubernetes mainly. But yeah, so you need to have some kind of way to orchestrate the work on your cluster, and that would be either Kubernetes or Yarn. You use Spark client tools to launch the job on the cluster, and then it'll process data from a location that you specify, whether that's HDFS or an object storage system like S3, or Azure Blob Store, or some clone of that, so something like ECS or Ceph. So that's basically how it works. You're not constrained, of course, to data in data storage systems like HDFS. You can pull data from a Kafka cluster or from a database, or you can push it. Likewise, you can push data to a system like that. You also have a few different ways of interacting with the data beyond Python and Scala. So you have a SQL API for Spark as well. So you can write SQL queries over your data as well as Python data frame like API. So that gives you more flexibility. And it also has, Spark has a thing called the Thrift Gateway, which allows you to connect BI tools to it and run true SQL queries over very large data sets. It's the kind of lakehouse concept.
So actually, that's really interesting. I have a question on that. You mentioned that Spark will pull in data from some storage or warehouse. It really doesn't matter as far as I understand. But then you also mentioned SQL and writing scripts to process that data. Is it fair to assume that the data has to be highly structured before it goes into Spark, or is there more flexibility in that? Could you show a little bit more?
It can be semi-structured. Typically, you're working with either highly structured or semi-structured data. So machine data, like log data, or JSON data or XML, you can process all of that. You can also process CSV data, obviously. But there does need to be some level of structure to the data. I think, doing pure NLP jobs. Well, you have modules that can extend the functionality of Spark so that you can do things like natural language processing over text data sets. But typically there is some structure to the data, yeah.
And is there a way of tracking that structure before launching a job? Is there a way of measuring that or evaluating where are my sources? How does it look? What's the types? That sort of thing.
Right. So if you want to curate the data, you would use something like Hive Metastore, which is a data cataloging tool to catalog the data that you have in your data sets, structuring them into tabular format. typically that's how you would do it. So you would declare tables in Hive Metastore, which would link with Spark through the Thrift Gateway, and you would associate your data sets, so your files of data, collections of files, with a table definition in Hive Metastore. Hope that makes sense.
It does. No, I mean, and from what I'm understanding, this is it's a tool that we can apply to both your standard ETL, but also to ELT. It really kind of depends on the workloads that you're using and where you want to end up syncing the data to at the end.
Sure.
That's great. Thank you. And I think that's given a really, really good overview of the common usage patterns. And what I am always a little bit embarrassed to admit is that as a software engineer, we tend to not consider security practices that much. It's not usually why we're brought in. And so I think it will be really good to start talking now about what are the potential causes and reasons for security threats to Spark deployments and Spark infrastructure. Massi, I know I have this image in my mind of security threats being this sort of black hat hacker crawling GitHub for any public credentials that you can find from a basement, or public IPs for vulnerabilities that they can then exploit for some crypto ransom. Could you probably fill in the blanks of that poor image on who the kind of people are that seek to exploit data infrastructure like Spark?
Yeah, for sure. I mean, if we think about Spark, what it is and what it does, it's fundamentally access and processes a large volume of data, which more often than not contains sensitive information. And also it is deployed on some very powerful hardware and many servers. And if you think about both data and access to compute, they are like very valuable resources that bad actors are trying to access. So, I mean, if you think about the main motivations for cyber attacks, they are fundamentally threefolded. So, in the beginning, there was this idea of like the classic activist, that the person that would like to just to do it for fun and watch the world burn. But like the reality is that the world has evolved into just targeting system primarily for two main reasons. One is financial, and the other one is like espionage or the world of like state-sponsored threats. If you look at financial reasons, the ones that are more relatable to Spark are fundamentally the ones that are involved into accessing and reselling data. So depending on the type of information that is collected from this big data system, they like an individual identity can be resold on the black market from just a few dollars all the way to hundreds of dollars if we're talking about information that can be connected to payment system or like iSecurity, personal information or medical information. Another financial angle is the everything that has to do with crypto lockers and ransomware. So effectively disrupting your operation and asking for money in returns. And finally, while we are far from the crypto highs of the past couple of years, access to compute is important and like highly sought after for both for like mining cryptocurrency, but like also for establishing botnets and sort of like enabling this distributed denial of service attacks. As I said before, I used to work in NCSC, so like most of my work used to be centered around like investigating this more sophisticated state-sponsored threats, which actually happen to be way more prevalent than people think they are, and they are also the ones that should be more feared because they are also the ones that are harder to detect and like in a way also more dangerous for the reputation of your company.
But if I understand right, it's incredibly common for threats to not be a rogue state, but also just to be disgruntled employees who maybe got fired and had too high level of access. And I think that must be both equally challenging to kind of secure and lock down. For internal bad actors, is it really just a matter of hiring the right people and people that wouldn't be vindictive, or is it something that is prevalent no matter where you end up being?
Yeah, I mean, Mark, you touched on a very important point. I mean, if you look at the Verizon data breach reports of, I think, the last 10 years, or anyway, since they actually started collecting data, you can see that like almost 40% of all attacks, they are done by they're carried out by insiders, and that number has remained pretty consistent across the years. Now, does it mean that we have a lot of bad people in our company? I mean, that's not what we are trying to say. The reality is that sometimes even the right people, that very experienced or people with good intentions, they make mistakes, maybe because they are tired or they're not paying attention, and those mistakes can cause loss of service, or otherwise vulnerabilities being mistakenly introduced into the system. So it is important to consider these sort of systems, not only with the classic castle and moat approach of we put a big firewall around it and we contain it, but making sure that there are multiple redundancies along the way, and implementing defense in depth measures as much as we possibly can.
Yeah, I have an example of a previous company that I worked at, actually, where it was during COVID when everyone had started working from home and no one had really figured it out yet. And a new starter had been hired and was going through their onboarding, so was a bit quiet overall. And then eventually stopped turning up to work and gave up. And they did a review of what that employee had been doing, and it turned out they had been just scraping everything they could from the accessible to the data science database, and they were just downloading as much as they can, storing it, and taking it off. And what I would like to know is what could that organization have done to avoid that? Because normally you want to give access to teams that need to be able to access the data. How can we make sure that we reduce the amount of kind of attack vectors that are available for potentially risky internal use?
I mean, the reality is that there is no universal right answer. I think that every organization needs to work out for themselves what that sort of fine thread between enablement and restrictions is. But at the high level, I mean, you always need to have a combination of what are called preventative controls, so the things that are in place to basically make sure that these sort of events don't happen, and detective controls, which are the ones that you mentioned. So making sure that there are, especially in the case where sensitive data is accessed, that there are manual and frequent reviews of employee activities. Now, this can be, I mean, will need to be carried out by human, and there are a lot of systems that can help you with that. I mean, the reality is that on traditional machines, this sort of anomaly detection system are very sophisticated, and have reached a stage, all the different dark trace or CrowdStrike and so on, that they provide a very good quality feedback. But in reality, this sort of capabilities in the Kubernetes world are still relatively nascent, and so there are a couple of cloud native projects like Falco, for example, that are starting to implement these functionalities, but it's still early stages and far from giving the complete visibility and the quality insights, automated insights that systems that operate on traditional virtual machine offer at this point in time.
Yeah, and I think that there's always so many potential causes for exploitation, either internally or externally, with credentials that are a little too easy to share, or there is some configuration on your entry points that means that it's completely insecure and accessible to the public outside of your whatever private network or VPN you're using. I know that I've had to do a lot of control of that in the past. I think what I find to be somewhat overwhelming is kind of tracking all of the different ways of understanding where are vulnerabilities within systems, as well as what steps can practically be taken to move to that in place. Usually, from my perspective, it's always just get me the data, just give me all the access that we need and just get me the data. And any roadblock to that ends up being a speed bump to the core cell of the organization. They want to use their data to achieve some goal. Could you give a bit of an overview on what practical ways or techniques or ways of thinking teams can use to start thinking about security as part of their day-to-day, both at the kind of management and executive level, but also at the engineering level, as opposed to something which I think is quite common, where code gets run and things get deployed and then it gets chucked over to the fence to some security team?
Yeah, for sure. I mean, I guess that the sort of like the initial step is one that doesn't even like necessarily need to involve security teams, and it is effectively understanding and taking a structured approach to like identifying and prioritizing what are the potential threats to the system, and then effectively determining the value that this potential remediation might have in reducing this risk. So everything starts from visibility. So documenting, in the case of Spark, like what are the data flows and understanding what are the potential entry points where, in particular, humans are involved. The traditional setup, if you think about Spark, is that you have drivers that usually are like employee machines. So that's like a primary way to start, and also, to be honest, like where the attackers would start as well. I mean, we talk a lot about open source, but code is open source. Also, like exploitation or reconnaissance mechanisms are open source as well. Like if you go on the Nmap repository, you can find a lot of like Lua scripts that can be run to inspect network traffic and find and basically identify like where the cluster manager like lives in the network. Just again by pattern matching some of the check existence call that are done inside Spark. So once the data flows are mapped out, I think that the second step would be to conduct what we normally call like threat modeling, and so identify the threats, and from that defining and prioritizing the security requirements.
Yeah, and I'm familiar with some of the threat modeling techniques. Actually, I think probably from your introduction of it with Canonical. But could you kind of give a brief description on what threat models actually look like, how they actually achieve their goals? For me, it seems like it's a lot of just conversation. How does it get turned into actual practice?
Yeah, for sure. I think the initial step is identifying. I mean, don't reinvent the wheel, and actually identify a framework that works for the business. And since we are in this case, we are talking about distributed systems. It is sort of like common practice to use a framework that is called STRIDE, and which is sort of like an acronym for spoofing, tampering, repudiation, information disclosure, denial of service, and execution. So elevation of privilege. So basically, what it does is, just after you've decomposed your system and your data flows, you pick each one of these sort of like 5 high-level categories and try to find like concrete ways of, so in the case of spoofing, trying to impersonate a specific user or service. It is also important to know that, actually on the CNCF side, there is extensive literature about that. So the threat model should not only should consider the system in many different states, and you primarily should complete this activity for the cluster provisioning, the scaling, the runtime part, so during the normal day-to-day operation of the system, during the configuration, and also consider your CI/CD pipeline. So the sort of like 5 high-level stages are what the CNCF or like the security community recommends in the area of distributed systems in general, and that's what we are also trying to do it at Canonical. So after you, go for it.
No. It was just a quick question, actually. You mentioned finding processes that work for the business. How do you know? How do you measure any of that? Do you just have a tally board of like has not been breached / hacked in N days and hope that number doesn't go down? How do you know that you are setting up processes in a way that is good enough?
Yeah, so everything starts, I mean, it is a business decision first and foremost. So like your business or you as architect of software should ideally have like a rough idea of what is at stake, and so what is the value that you pose on the continuity of your operations and on the value of your data. I am like here at Canonical, and personally, we are a big proponent of the FAIR, which is sort of like a risk evaluation framework that define risk as the product of the loss event frequency and the loss magnitude. Now, the magnitude of the loss is what I was mentioning before, and that's something that by implementing security controls we are not necessarily able to affect. I mean, your data is as a value X, and like adding authentication, removing authentication to your cluster is not going to change that. But where we can, as architects, as cybersecurity professionals, what we can influence is effectively the susceptibility of a system of the occurrence of a certain threat scenario. So effectively, by tweaking this knob, we try to come up with a with a risk level that is acceptable for the business, and eventually just basically quantifying that in a dollar amount. And the FAIR framework allows you to do that in a way that the boards or other business people are able to understand.
Oh, that makes a lot of sense, and thank you very much for kind of your experience on that. I think now bringing this kind of back to Spark specifically, I was wondering if we could get a bit of an understanding of what sort of tooling and support is built into Spark already that teams and organizations should be using and leveraging to kind of patch the holes. Rob, could you kind of walk us through what exists already?
So I think the first thing to mention is that nothing is enabled by default. So none of the security features with Spark are there out of the box. You have to enable them. But you have capabilities for transport encryption, at-rest encryption of spill files. So spill files is like when a job has intermediate steps and it needs to page stuff out to a disk. You have spills over from memory to disk. You can encrypt those files. Spark can encrypt them. So it has that. You have integration with authentication mechanisms, so like Kerberos or the native authentication of your Kubernetes cluster if you're using Kubernetes, for example. So you can leverage certificate-based authentication or OIDC typically on your Kubernetes cluster itself to authenticate users. And you have what else do you have in there? Those are the main features. It has integration with role-based access control systems like Ranger as well. So if you want to implement Ranger on top to regulate access, you can use that.
I have a question. I have a question
Yeah.
on the roles side, actually. Something that I've noticed from slightly less mature data organizations is usually they'll have a pattern where you have this very overworked and understaffed SRE team that are given complete super user permissions for almost every inch of the entire end-to-end pipeline, both from the data storage to the processing and to the syncs. And other teams have almost no access, and so that they will usually have some internal system in place to request jobs, and then that data gets the output of those jobs gets materialized somewhere else without any of those security controls, and it sort of ends up being a bit of a bottleneck through that SRE team, but also a potential risk. And usually these orgs kind of state that they don't have the resources to sort of integrate more fine-grained controls. Could you, what do you see as the kind of potential risks for patterns like that, and what do you think needs to change?
Well, so first of all, if the data wasn't valuable, there wouldn't be a big data cluster in the first place. So the data must have some value. So the risk is that, you know, if you're leaking data from a highly elevated privilege team, or from the egress data that comes out of the system is being left on laptops or whatever, you know, you have a huge risk of a data breach of your valuable data. So you know, there's not much that's going to cover that. You can try for insurance, but typically insurance doesn't cover these kind of data breach events. So, you know, they need to step up their game. It's as simple as that. If there's a value to the data and they're spending good money on processing the data, then they need to be spending good money on securing it too.
And for those people using cloud providers for their storage and their K8s runners that actually process the jobs, what setups could teams kind of focus on in the short term that provide the kind of most bang for your buck in terms of securing that? I mean, I'm sure if it's the cloud, then it must be secure, right? And I'm sure that's not the case, but I'm hoping you can tell us more about that. Again,
it's going to be the perimeter access that's going to be the biggest concern. So that and misconfiguration. So I think there's two things I would consider first and foremost. One is perimeter access. So how do you access your data in your big data environment? So if you're connecting directly to it through a VPN, maybe you could consider putting bastion hosts or jump boxes between, having like workspaces on the cloud where your users have to access the workspace in order to access the data lake. So there's some level of governance between the end users and the data. And then secondly, using some kind of GitOps for configuration management, so that the configuration of your cloud environment is in a known state at any given time. Does that make sense?
No, it does. It does. I actually have a question on that for both of you. I was hoping you could give an overview of what should teams do when a threat, a real threat, has been identified and exploited. They've had maybe a data breach, they've had maybe machines being shut down and data loss, or someone has published that they are begging for crypto, or they'll release XYZ. What can teams do about that?
I think there's a couple of things that spring to my mind. I'll let Massi answer in a moment. But so first of all, teams should have a business continuity plan in place, so that they already know, they've already thought through these these scenarios, and they already have a rehearsed response to any of these given catastrophic events, essentially. So that's the first thing I would say. From a kind of technical measures perspective, because really this is about people, processes, and technology, we need to keep that in mind. But going into the technology side, I don't know if you've heard of SOAR, so Security Operations Automated Response, but it's a way to automate response to, these kind of events taking place. So if you detect that some bad behavior is happening somewhere in your environment, then you can have automated measures that shut down access, isolate it off, close off the network, then snapshot VMs, for example, for forensic analysis, that kind of thing. Yeah. So, Massi, if you have further thoughts there, please speak.
I think that those two are very good points. I think that the automation side is very important, not only for how do you respond to the actual security incident, but more broadly, sometimes there are instances where you have to rebuild your environment. There is no way around that. It's effectively the most efficient and effective way to remediate the security issue. And in that case, automation around your builds, traditional T builds is important, and also automation around patching and making sure that you are like as up to date as possible, because just like you get to know about the vulnerabilities that are out there, so are the attackers. And that, if you want to talk about a concrete example, at the end of 2022 in December, there was the zero bot malware that it was initially targeted at like IoT devices. So something that has got nothing to do with Spark was modified to take advantage of a vulnerability into the Spark UI. And ironically, in a part of the Spark UI that is supposed to enable ACLs, right? So like a security feature of the Spark UI to effectively just open up remote shell on all the machines where there were worker nodes, and then use those to effectively launch denial of service attacks, and offering those nodes effectively up for a botnet for hire. So again, automation, I think it's key in terms of security response, but also builds and security patching.
Yeah, you mentioned that one of the best processes just redeploying the new infra, and it really helps to have scripts or something like Terraform or Ansible to make that a lot less painful. I think if I remember from a conversation with you in the past, I think one of the reasons for that being so effective was because it's quite common for once machines do get exploited, it's common for people to install backdoors. Am I understanding that right?
Yeah, that is correct. Thinking from an attacker perspective, there is it's very common knowledge in the security environment that all cyber attacks, they follow like a similar pattern, and that's summarized into what is called the cyber kill chain. And so after the initial reconnaissance part, which in the case of Spark, I think that there are ways that it can like relatively trivially be done. So it's relatively trivial if you have access to an internal network to identify where, for example, that the cluster manager said. Then the second step is effectively the intrusion, exploitation, and privilege escalation of those hosts. And I guess that the ultimate scope of what all attackers would like to do is like open remote shells and establish persistence into the system for whatever they to deliver the payloads that they would like.
Thank you. I think that something that's quite common is teams will be looking at managed solutions. Usually, the most common for Spark is obviously Databricks, but when they're running on a managed cloud, so ideally not a public cloud in this case, is all of their security taken care of? Do they need to care about it? Or is it something that it still needs to be vigilant from the users and the organizations that are using it?
There's been so many data breaches of S3 buckets If you're building a data lake on AWS and you're using S3 buckets as the backplane for the storage, and you're using, I don't know, EMR or lake formation for your Spark cluster, then you still need to be vigilant. A misconfigured bucket that's got the wrong permissions assigned to it is a great way to expose your data. For example, the Spark history server is a component of Spark that's used for aggregating logs and metrics from the cluster. If it's aggregating logs from S3 and your Spark jobs are writing their logs to S3, you would ideally want to have a separation in terms of the IAM role between the Spark history server and your job. So, I mean, I'm not sure if that's done by EMR. I suppose it is. If it's not, then you should separate out the roles of the different components of your cluster. The same goes for your users. So if your users have got privileges that they don't need, then that's something you need to address as a matter of urgency.
Yeah, and with these sort of off-the-shelf solutions, if they're not running on infrastructure that you have administrator access to, maybe it's their cloud, what can you do about that? Do you have to just trust that everything is safe, or do you, because you have some sort of licensing agreement with them, or do you have to take account of things before that?
Sometimes if a service provider has a level of compliance, then they'll be audited on a regular basis, and you can request access to their auditor's report, and sometimes they'll grant that. I think that's the best you can hope for. It is something of a risk of supply chain hackery if you go that route, frankly.
Yeah. Okay, great. Well, I think we've ran on for about 40 minutes now. I think we can probably leave it here and open up to any questions that people might have. And again, if we'll try and answer as many as we can while the session's going on, but do please leave your questions in the comments and we'll try and get to you as much as possible. But in the meantime, thank you very much, Rob and Massi. This has been, for me, a really, really helpful session. I hope for everyone joining this webinar today. Thank you very much.
You're welcome. Thank you.
All right.